session 11 of this Python and Data Analytics Internship, October 2025. So, in the earlier lectures, we have covered about the introduction and that what is data analytics and what is the use of it in today's scenarios. Okay, so I told you that we will be understanding the core of data analytics, that is NumPy, Pandas, and Matplotlib in the coming sessions. So today, to move further with NumPy and its capabilities and its power, we are going to understand it better and how to manipulate array and what is broadcasting basically. So today's topic will be array manipulations and broadcasting. So the objectives that we have decided to cover in this lecture are as follows: like understanding array manipulation in NumPy, basically how to manipulate the arrays and the data within them using NumPy and its features. All the things that are pre-built in NumPy, we call it like functions. So NumPy has a very large set of functions which will help you to manipulate the data in a manner that you want. Perform reshaping, stacking, and splitting. We will be seeing this in the further slides. Apply broadcasting rules for arithmetic operations. We will understand it better when we will deal with this topic, that what basically broadcasting means. And lastly, execute element-wise operations between arrays. So let's start. So as I told you earlier that what is NumPy basically? Okay. So NumPy is a library of Python that deals with array manipulations in data analytics. So anything that you have with you and you want to perform some scientific calculations like matrix multiplication, cosine, sine, and any other calculations that you want to perform, transposition basically, or creating identical matrices, these things help in data analytics a lot. So NumPy provides the capability to deal with all the scientific calculations in the n-dimensional arrays. Basically, what our matrices are, they are n-dimensional arrays. Like we have n number of columns and m number of rows. Okay, so instead of calling it as a matrix, we call it as rows and columns or n-dimensional arrays in Python, basically in coding language. In maths you call it matrices. In Python we call it as n-dimensional arrays. Because these are arranged in the form of arrays in n number of columns and n number of rows, as you are able to see that in this output. If we remove these square brackets, you will find it like 1, 2, 3, 4. It is arranged in a matrix format, but we call it an n-dimensional array or 2D array basically, because we have two number of rows here and two number of columns, so it will become 2 into 2. Okay, so NumPy arrays are n-dimensional containers that hold homogeneous data types. What homogeneous basically means, all the elements will be of same type. Like if they are float, they will be float. If they are integer, they will be integer. Okay, so very noticeable thing here is that in list we are able to store any element of any type, whether it is a string, it is a character, or it is an integer, or it is a floating number. We are able to store it in a single list only. But arrays in NumPy, basically using NumPy, the arrays which we create using NumPy are restricted to a limitation that all the elements within those arrays will be of same data type. Okay, so NumPy is used to create arrays but with same elements of same data type. Okay, like you are able to see in this example, we are basically importing NumPy as NP. I told you that AS is used as a short form for LES. Okay, like you have your real name in your home. Okay, and then you have your nickname. So basically, we are assigning NumPy its nickname as NP. You can assign it as any name you want. You can assign it as S, Z, or any letter that you want. But why we are assigning it as a nickname? Because we are basically type, or we are basically uh, shorting the length of the name. We are using it short form like np.array instead of numpy.array. This is the syntax basically to call the numpy functions. Python will come to know that you are telling it that you have to call this numpy. From this numpy library, you have to call this function array, which is used to create a two-dimensional array. So this is what this code says here. So there might be a question in your mind that why we are using arrays if we have list and we can deal with all the elements in a list also. List is basically like an array. So why we need to use an array? Basically, why we need to use an array? Why can't we use list? We can also perform operations on list. We can create a nested list, one list inside another list. Okay. So why to use arrays basically? So this array concept comes from other programming languages like C, Java, etc. There we don't have list types. In C and C++, we don't have list. There we have arrays. But in Python, we have list. C and C++ strictly defines that all the elements stored within an array should be of same data type. Okay. But Python list provides us the capability that we can use any data type or any type of element in the same list. So in order to separate this thing from the array thing, we are basically here using capabilities of C and C++, not of Python, to create arrays. Due to which there come some differences between list and arrays. First is faster computations. Faster computations are basically because Python list, let me explain you some third point first, less memory usage. In Python, the data is stored basically in 28 bits. The pointer points to 28 bits, bytes, sorry, bytes. So it takes 28 plus 8 equal to 36 bytes to store a single element. But in C and C plus O, in C and C plus plus, when we create an array and store an element in that array, it takes only 8 bytes. So we can obviously see that there is a significant difference between the memory usage that Python is taking to store a single element and arrays are taking to store a single element. So this you should know that this memory usage is less in Python. Oh, sorry, it is less in arrays and more in Python. Every time you write a coding question or you go for a solution that you are presenting to a customer or you are doing coding, two two things matters the most. First is complexity and second is its memory usage. Okay. So complexity is basically it deals that how much computations you are performing on that particular thing in order to achieve a result. Like if you have to multiply a number 3 times, then you are doing 3 into 3 into 3. But suppose if you have to multiply a single element with other elements, then you are putting a loop there and then multiplying it with every element by accessing that element from that array. So there the computations are getting increased if you are using loop. Python, basically in Python, if you want to change, suppose you have a list in Python which is 1, 2, 3, 4, 5, and you want to multiply that whole list by 2 and add 3 to it. Okay. Then it will, in the background, it will implement a loop behind that thing. And that is going to increase the number of computations that Python is going to perform in order to give the end result to the user. So that's why its computation speed become less. And in arrays, the computation speeds become faster because there some steps are omitted that are additionally implemented in Python. That's why faster computations are performed in arrays, and in lists, the computations speed is basically slow as compared to arrays. It is not as slow that you can see by naked eye, but if you go really behind the code and the behind the scenes thing, then you will find that it is slightly slower than the arrays computations. Also, we will see about that in the second point. It is mentioned as support vectorized operations. Okay, what I was telling you, that there is a loop implemented behind the scenes. Okay, but in Python, in order to calculate in order to multiply a list by any number, but in arrays, that behind the scene loop is not presented. No explicit loop in order to perform any operations. You will see in the upcoming example that what I am talking about. It might be a little bit confusing right now, but remember this: arrays support faster computation. We all want that as a solution must be a faster one. It should take less memory, and vectorized operation basically no explicit loop behind the scene. Okay, so let's move to the next slide. Arrays, also one thing forgot to mention you. If you think that these arrays are the explicit feature of Python, then you are wrong. We are using basically C and Fortran features in order to implement those arrays in Python. Okay, remember this point. It might come in your interviews or etc. Because when we are performing computations on Python, they move the heavy work into optimized C Fortran, C or Fortran language. These are two basically coding languages which support vectorized operations. No explicit loop is required in order to perform computations, basically. Okay. So the Python level overhead is present in performing operations in Python is not present in arrays. Now let's see about array manipulation and reshaping. That what basically array manipulation is and how to reshape those arrays. So as you can see that reshaping means changing the shape of something. It can be anything. Okay, so in Python, if we are manipulating arrays and changing it into, like we are changing one dimensional array to two dimensional array or two dimensional array to one dimensional array, basically we are changing its dimensions in order to analyze the data better, or in order to manipulate the data in a way that we want. We have to somehow shift some things above, some things below, according to our needs, so that the analysis on that particular data, or like the cleaning operations that we are performing on that particular data, will become standardized, or should take a flow in which you want them to flow. Then only you can analyze your data better. You will understand this point clearly when we will do EDAs, elaborated data analysis. But right now, you should know that what array manipulation means and what it is going to support, or providing the features to us so that we can manipulate our data. So reshaping changes how data is organized in the array without altering the actual data values. Okay, we can change the manner in which, like you in your classroom you are sitting and you have chairs and tables with you. Okay, so they are arranged in specific rows, and if you see them through columns, then you can find them that they are arranged in column wise also. So you are moving those, some chairs and benches forward, some backward, or you can you would be mixing two rows into one row to make some space in the class so that you can perform some fun activity that the teacher is going to tell you. Okay, so basically you are only changing their arrangement. You are not changing their values. Okay, you are not changing their dimensions, but only the arrangement is going to be changed. So that is also the thing that we are telling you, that reshaping basically in Python means changing that array without altering its value. If 1 is present, then we are not converting that 1 to 2. We are only changing the place where 1 is sitting to another place according to our convenience that we want. Okay. Use case, what and now to address your question that why we need to reshape these arrays basically. So reshaping is commonly used when preparing data for machine learning models which would expect structured inputs like rows and columns. That is what I was telling you earlier, that you have to organize your data in a way so that it can be understood by the model, and your model can be trained on your data, and then when your model is trained, it can perform predictions and the end results that you want it to perform. Like, to guess what are the chances of a person having asthma, of you will provide the details like this is his age, he is living in that city, this is the AQI of that city. Then model will predict that what are the changes that person is going to have asthma in future or sugar in future. Sorry. So in order to train your model so that it can perform the predictions, you need to feed it a data that is well organized in rows and columns so that model is able to understand it. Like in the morning assemblies in school, everyone is scattered, basically roaming here and there. When the bell rings and some instructions are provided to you, you form a particular line of particular class, like class 1, 2, 3, 4, 5, 6. So you are, everyone can easily distinguish that this is the line of class 1, this is the line of class 2, this is the line of class 3, and all the students that are standing in that particular line belongs to that particular class. So it becomes easy to distinguish between the students, categorize them, and then you can assign tasks to those students according to their capabilities. Okay, similar thing we are doing here. We are getting the data which is scattered everywhere, but we are arranging it in rows and columns so that our model is able to categorize those datas and perform operations on those datas, get trained on those datas, and then predict what we want it to predict. That's why reshaping becomes very important in data analytics. So what is array stacking and splitting? Stacking basically means combine multiple arrays into one. And splitting, as it suggests, divide arrays into smaller chunks. Chunks are group of elements that you have created by dividing the original array. Like in this example, you are able to see a equal to np dot array. Then you have provided some values here. Okay. Then you are printing np dot h stack. This is the function h stack, which is used for stacking a comma b. Okay. So h stands for horizontal stacking. It will arrange them in horizontal way, like 1 comma 2, then 3 comma 4, and then 5 comma 6 and 7 comma 8 in one row basically. If we use np dot v stack, then it will arrange them vertically. Okay. So let's see if we can perform some operations on VS Code. So in order to call your NumPy, you have to write like this as np. Okay. Now, when you create an array, you have to define a variable equal to np dot array, and then you can create your array inside it. Okay, this is the syntax basically. Now, if you have an array like we have in this example, as you were able to see that we have two arrays here, and that two arrays belong to basically has two rows and two columns. Why? I will show you by writing it. I am writing it roughly first, if you have a matrix, it will be like this in maths. Comma 2, comma 3, comma 4. Okay, I am removing this. And then you print that array, print it. So you will get it in one row only. Okay. So you will, as you are able to see that you are getting in one row only. Every element is one row because you are defining only one here. If you defined it like this, 1 comma 2 and then comma 3 comma 4. Now an error might come. Okay. Let's see why this error is coming. Because Python is not able to understand that what you are doing. First you have created an array, then you have created another array. Python is not able to understand this syntax. So in order to create array inside arrays, you have to define a parent array. Like, I will clear this first so that you are able to understand easily. Now this is our parent array. The array which contains all the arrays, n number of arrays that you want to define inside it. Now you define 1 comma 2. Now Python is interpreting as that, okay, there is one parent array. Inside that parent array, we have defined another array that is 1 comma 2. Now we have defined second child array that is 3 comma 4. Now let's see the output. As you are able to see, we are getting 1 comma 2, 3 comma 4. As I have written earlier, the matrix will look like this. Okay, so this is how things are arranged in Python basically. So we have two rows and two columns. If you want to add more, you can add more. N number of times you can add inside it. Like comma, I am adding 5 comma 6. So one more row is added and column number remains the same. Because we are not changing the column numbers, we are only increasing the number of rows. The time you create an array, the n times you create an array, the n times the number of rows increases. If you want to increase the number of columns, you have to increase the number of elements inside it. Okay, the column number now get increased because we have increased the number of elements inside that child array. So this is what it actually means to create an array. So currently this is our output right now, but we want to create two arrays so that we are able to see that they are getting mixed or not, or getting stacked or split or not. Np dot array, another array. This is our parent array. Inside that parent array, we are going to define our child arrays. You can define anything like 5 comma 6 and then 7 comma 8. Okay, now we have our two arrays. If we want to print them, we can see print b. Okay, so this is our first array and this is our second array. Now we are going to use our function that is hstack and vstack as we have used it here. I always told you that you can do. Now np dot, we are going to use h stack. Then in h stack we are going to basically combine a comma b. Okay, so what it is doing basically, as I told you, that you will be able to understand when we will do it practically. These things, it is taking the two first child arrays, basically two first rows from those arrays. Our matrix was like this now: 1, then 2, then 3, and then 4. Second matrix was like this: 5, then 6, then 7, then 8. So what it is doing, this is our array A, this is our array B, 5, 6, 7, 8. Okay. So it is taking first row of array A and first row of array B and is arranging them. It is basically doing the stacking horizontally. Okay, like this. So it is taking the horizontal way. Horizontal way means rows. Okay, because our rows are horizontals and our columns are verticals. And in the next, you are able to see that 3, 4, and 7, 8 are combined. Okay, now let's comment out this thing. Let's cut it. Now, if we want to perform V stack, we only change H to V, and then let's see the changes. Now it is getting vertically arranged. 1, 2, 4, 3, 4, and 5, 6, and 7, 8 for vertical. It is now arranging them in columnar format. Earlier, it is arranging them in horizontal format. So this is what H stack and V stack basically means. Now our second function that we are going to understand was basically splitting. It is also H split and V split. Here we have defined only H split. So as you can see in this function, we are telling it, okay, this is your array 1, 3, 4, 5, 6. Now Python, you have to use the Python NP, yani NumPy library of Python. Inside it, you have function hsplit. Using this function, you have to split a, comma 3. Means you have to split this array 1, 2, 3, 4, 5, 6 into 3 parts. So Python will intelligently divide it into 3 parts. Let's see. 5, 6. Print np dot h split. Now, which array we have to split? A. In how many parts? 3. As you are able to see that this array is divided into 3 parts. Now, here we have 6 elements. So it is dividing it evenly. What if we have only 5 elements and we are telling it to split in 3? We will get an error. Okay. And if we change it to 2, why this is happening? Basically, it depends on the number of elements that you are passing here. It should be divided by the it should be divided by the length of array. The length of array should be completely divided by the number that is going that the number of times you are going to split that array into. Okay, like I am here dividing it by a length of array is basically 6, dividing it by 2, it comes basically 3. Okay, so it is getting completely divided. मतलब remainder is zero basically. Then we are able to split this into two parts. Now, as in maths, we have array transposition and axis manipulation. Basically, what it means, we will see it here. Transposition means flipping rows and columns. Okay. What it means, flipping rows and columns. Like column will become row, row will become column. As in this example, you have 1 comma 2 and then you have 3 comma 4. So when we do a transposition operation on it, the rows will become column like this, and the column will become another row like this. Okay. So 1 comma 2 was a row. Now it has become a column. 3 comma 4 was a row. It has become a column now. Okay. 1 comma 3 was column. It has become a row now. 2 comma 4 was a column. It has become a row now. 2 comma 4 means rows will become columns and columns will become rows, and it is a very important operation when you are doing data analytics. Many times you have to perform basically transposition on the set of data that you have. You will understand it better when we will do EDAs in the upcoming sessions. So for now, remember this we can also perform transposition. All the matrix operations can be performed using NumPy capabilities. Okay. So that's why NumPy becomes very important. So A dot transpose, basically it is in uh, maths also you have seen that for the transposition array we use T. Okay. A dot T, it represents that the transposition operation has been performed on that particular array. In maths also similarly we represent it in Python also. A dot transposes the array, rows and columns are interchanged between them. NP dot swap axis a comma z 0 comma 1 is more flexible for higher dimensional arrays. Higher dimensional arrays basically means when your number of rows and number of columns is very high, then you can perform this swap axis. Axis basically means you are swapping those arrays and columns only, but it is used for higher dimensional arrays. For two-dimensional arrays, three-dimensional arrays, four-dimensional arrays, we can use A.T. Use cases: image processing, switching pixel axis, width and height. Okay, width is arranged basically in horizontal format and height is arranged in vertical format. In order to understand our image data, we sometimes we need to switch its pixels. We have to convert rows into columns, columns into rows. When we are going when and it usually happens when we are training our model, machine learning model. Okay, you need to feed it a different types of data. Suppose you are training your model on the images of animals, pet animals basically like dogs, cats, and you want that you will provide a picture to your model and your model will identify that which animal is this. Then you cannot simply feed the model very simple pictures like a dog is sitting, you are simply feeding it. Sometimes you have to jumble those picture pixels, rearrange them in a way that a human cannot understand but machine can understand. You have to feed it different types of data. The diverse your data is and the larger your data is, the larger is the accuracy of your model. The simpler your data is and the small your data is, the accuracy of model decreases a lot. So in order to increase the accuracy of our machine learning model, we basically feed it different types of data, similar data in different formats. Okay, the image can be same, but it should be rearranged again and again, 10 times, 100 times and 1000 times. Then you are feeding it to the model. And for example, you are rearranging the pixels of one image in 10 ways, and you have 10 thousands of images. then you are basically feeding 10,000 types of data to that model from 1,000 images. So that if in future you are feeding a blurred image to your model or a very unclear image to your model is able to understand that which animal you are telling it to identify. That's why this transposition becomes very important. Matrix computations, linear algebra, and rotation operations, these are basically all maths operations, but they help us in providing different types of data to our machine learning model in order to increase its accuracy or and in order to increase the diverseness of our data set. So it is very simple. You can simply declare the array as we have declared earlier. You can print a dot transpose for transposition, swap rows and columns manually. You can use np dot swap axis. Okay, A stands for array, 0 and 1. Basically, it stands for rows and columns, which you want to swap. Now, what is broadcasting? Broadcasting allows NumPy to perform arithmetic operations on arrays of different shapes. Instead of looping through each element, NumPy expands smaller arrays to match the larger ones automatically. Okay, so let's understand the first point first. What is broadcasting? I was telling you earlier that it supports some what we call vectorized operations, so that loop should not be required. Okay, wait a second. Now, consider a scenario. You have an array and you want to multiply it with 3. Every element by 3. What you will do? You will use for loop, access each element of that, then you will multiply by it 3 in list basically. Okay. So you will what you will do? Okay, we are accessing 0 index element, then multiplying it by 3 and in storing the updated value on that particular place. Like we are multiplying first element of our list is 1, then we are multiplying it by 3, it becomes 3, then we have to store that updated element in place of 1, and you have to perform this operation by using a loop. Okay, you are basically using a loop, for loop, and then you are performing the operations. So the number of times you lose a loop, you use a loop, okay, the complexity of your solution and the computation of your program increases. Basically, if you have a array and you want to perform into operation into it in list basically, so it will take n number of times complexity in order to perform that particular operation. Suppose your array your list length is 5 and you want to multiply it by 3, then your loop will run 5 times, so its complexity becomes order of n, O n, ठीक है, because it is running n times. Now suppose you have a nested loop, a loop inside a loop, and then you are performing some operations. You have to write some logic. So loop inside loop will run n times, and the outside loop will also run n times. Then it becomes n into n, basically n square. So its complexity increases. So number of times your nested arrays occurs and perform operations, the more its complexity gets increasing. Computational power becomes very low. It takes a lot of time, lot of memory in order to perform a single operation. But broadcasting in NumPy allows us to perform those arithmetic operations on array without using a loop. You only have to tell Python by using NumPy that I want to multiply all the elements of this array by 3. It will multiply all the elements of that particular array by 3 without using a loop. So the complexity that we were having earlier, that is order of n, is now is not able to occur now. That's why broadcasting becomes very important. It lets NumPy perform arithmetic operations on arrays of different shapes without writing loops. Okay. We have two rows and three columns. And we have second array 10, 20, and 30. Okay. Now, what we want is that we want to add those two arrays, A plus B. Now, what the output will become? 10 will get added to this one. It will become 11. 20 is will get added to this 2. It will become 22. 30 is get added to this 3. It will become 30 or 33. Now, this smaller array will get added to now this second array. Okay. Now 10 will get added to 4. It will become 14. 20 will get added to 5. It will become 25. 30 will get added to 6. It will become 36. We will see it in the code editor also. But get the idea first. This is our smaller array. That is what our second point was telling us earlier. This smaller array will get to this first part of the n-dimensional array. Then this array is broadcasted to this and will get added to this. And end result will come like this. Why? Because in the original array, we have two rows, three columns. So our output will also give two rows, three columns. There are some rules of broadcasting that you should remember. Dimensions must be equal or one of them must be 1. Okay. What it means? If it has three columns, then the array that we are adding should also have three columns. One more point. One array should have 1D array. Means one dimensional array. Only then you are able to add these two arrays. So one should be a smaller array compulsorily, so that we are able to perform those arithmetic operations. Similarly, you can perform multiply operation also. 10 will multiply by 1 equal to 10. It will become 40. It will become 90. Similarly, it will become 40. It will become 100 and it will become 180. Let's see with an example. Okay. Now we have this two rows, two columns in this array. Now we have B array, np dot array, and it we have 1, 2, 4, 2, 3. Okay. Now what we want to do is, can remove it. Now we wanted to print A plus B. As you are able to see, 2 will get added to 1, it will become 3. 3 will get added to 2, it will become 5. Now 2 will get added to 4, it will become 6. 3 will get added to 5, it will become 8. They are getting added to one particular element only. Okay, first element to first element, second element to second, first element to first element of second child, second element of second child. Okay, in this way they are getting added. We can perform multiplication also in the similar manner. Okay, now they are getting multiplied. But what if we were using list? I'm just giving you a hint. Like suppose we have a list L equal to 1 comma 2 comma 3 comma 4 comma 5. Suppose only for now take this as an example. Okay, 1 comma 3 4 5 लिस्ट में स्क्वायर ब्रैकेट होते हैं. This was our list earlier. If you want to add or multiply any element, suppose you want to multiply to this list, so you will take for I in range, you will give the or I in L. Okay, then you will go and multiply every element of that list. Suppose L of 0 you will take, or L of I, or I. ठीक है, मतलब you will take first element of this list and then you will multiply it by 2, and then the updated value will be getting stored here on the first element of that list, L of 0. Okay, so this is how you are going to basically perform operations. But in order to multiply this list by 2, you are using for loop. But in the above example, as you are seeing, we are not using any type of loop. We are simply using A into B. You cannot multiply two lists like this, L into L1 into L2. Okay, suppose you have two lists L1 and L2, you cannot multiply them like this simply. You have to use two loops to multiply those lists. One for loop outside, one for loop inside. Then you will multiply them. And it will increase the complexity to n square. Also, it will take a lot of time for the computations. Although for you, it is not a lot of time. But as a programmer, it is a lot of time. That's why broadcasting becomes very important in Python. Broadcasting in action, basically, it is of two types: scalar broadcasting and multidimensional broadcasting. What is scalar broadcasting? When you are simply multiplying the array with a single digit, like this. You have this array and you want the elements of this array to get multiplied by 2. Every element of this array to be get multiplied by 2. Then you can simply write a into 2. Then every element will get multiplied by 2 and the result will look like this. What is multidimensional broadcasting? In the previous slide, in this slide, this was multidimensional broadcasting. Okay, the example which we understood earlier was of multidimensional broadcasting. Why multidimensional? You are multiplying n number of rows and n number of columns with a one dimensional array. So you are performing operations on different dimensions. First row, second row, third row. Okay, first column, second column, third column. So it was of single dimension, only one row. It has 3 rows. So number of rows equal to number of dimensions. It will become 3D array. Then you can perform the operations on it. It will become multidimensional broadcasting. Meaning is same. You are not using any loop to perform arithmetic operations on array. Multiply, divide, modulus, anything you can perform. These are some common examples of array manipulations, and these the array manipulation functions are not limited to these functions only. It has lot and lot of functions, but the most common functions that we are going to use will come in use through practice. The more you practice, the more you will get to know that what are the functions that need to be remembered. Otherwise, you can refer to some online documentations on array manipulations, or can take help from any other websites to understand those meanings. But when we will do practical examples, you can easily identify that which functions are important for us, because they will come again and again. And the things that are repeated, they becomes very important. Reshaping is very important function. I told you, changing dimensions 3,2 array to rows and etc. Rearranging them basically. Transpose, swap axis, a dot t, or we can use np axis a comma 0 comma 1. Concatenate, it merges two arrays. It merges two arrays into one. As we have seen concatenation in list also. Similarly, it applies to arrays also. You can use np.concatenate. A comma b will be merged together. Expand dimensions, add a new dimension. If you want to increase more rows or more columns, you can use np.concat. Sorry, it get repeated. This function is expand dimensions. Okay, it's a typing mistake here. Sorry. Squeeze, remove single dimensional entries. Single dimensional entries basically having only one row or one column. Okay, and the data that you don't want in your rows and columns, it will clean that single dimensional entries. So assignment for this lecture will be perform element wise operations on 2D arrays. Okay, that is NumPy. Wait a minute. Okay. So what is your assignment that is going to be for this lecture is basically perform element wise operations on 2D arrays using NumPy. Basically, you are going to use broadcasting, or you can use for loops, or you can use any other method that you want. To solve a single problem, there can be many methods which you feel free to use, which you think that you are able to use it, or there is no single set of guidelines to solve a single problem. You can approach it by different methods, but in order to perform element wise operations on 2D arrays, and if you are using NumPy, simply it means that you are going to use broadcasting. Create two 2D arrays, 3 into 3. Basically, three rows will be there, 3 columns will be there with random integers. Perform a print results of addition, subtraction, multiplication, and division. We have seen addition and multiplication in this lecture only. In that way only you have to do it. Demonstrate broadcasting by adding a 1D array to your 2D arrays. Okay, as we have seen in the lecture that we have 2D arrays, that 2 rows and 2 columns, and then we were multiplying it with a array of 2 into 2. We were multiplying it by 1 comma 2 or 2 comma 3 in the lecture. So like this only, if you have 3 rows 3 columns, your 1D array must be of 3 columns. Okay, and of single row. So that are the rules of broadcasting that we have seen. So you have to create a 2D array, 2-dimensional array by 3 into 3. That 3 rows and 3 columns will be there. Then you have to perform addition, subtraction, multiplication, and division on it using broadcasting. Then demonstrate that by adding 1 comma 2 comma 3 to your 2D array. Assignment URL is this. You have to upload the assignment on this particular URL. If you want any support and help, you can contact us here. And thank you for joining today's session.
Sir, I have a excuse me, sir.
Hello?
Yes, sir.
Harsh, were you
Yes,
speaking?
sir. I wanted to ask, is it necessary to be?
Hello? Yeah,
Yes,
yeah.
sir. I have a doubt.
Yeah. Tell me.
Subject in 11th
Not
and
audible.
necessary to
Harsh, your
have
voice is
maths
breaking.
as your
I'm not
subject in
able to
11th
hear
and
it
12th
clearly.
to be a data scientist.
Harsh, your voice is
Clear
breaking.
now?
Can you type it in the chat? Yeah, I'm able to hear you now.
Okay, sir. Okay, sir.
Please ask your question.
Yes, sir. I wanted to ask, is it necessary to have maths as your subject in 11th and 12th to be a data scientist?
No, Harsh. It is not compulsory at all. In maths, you have to learn through logic and you have to do the computations yourself. Here, everything Python is doing. You only need to know that row, like I have given you an example. Why I relate it to maths is basically because many of the operations are same that you have performed in 11th 12th. But if you don't have maths as your subject in your 11th 12th, then it is not necessarily important that you will not become a data scientist. But you have to understand the core concept behind it, that what transposition means. Transposition means basically we are converting rows into columns and columns into rows. And in real life, how it will help, we are going to rearrange the pixel. That you already know na, the image is made up of pixels, and those pixels are arranged in rows and columns. In order to change their position, we are performing transposition. You have to understand the meaning only. How transposition is performing, how the computations are going on, these are all headache of Python only. But you need to understand the meaning, that what transposition means. These are some things that you need to know in data analytics, because if you are not aware that what transposition is doing, that it is changing rows and columns, this much you should know. That's why data analytics is becomes related to maths a lot. But if you don't have maths with you, you should try to understand the core meaning behind it, not the logic or implementation behind it. Okay.
Okay, sir. Okay, sir.
But in interviews, like you have asked a question, let me see. No, in interviews, they will not ask to perform the computations by yourself on a data. They will only ask that you have, they will provide you a data set, and they will ask you that, okay, perform some operations on this data set and give us the insights. If you know that what you have to do, how you have to clean that data, everything Python will do. You only have to follow a particular set of instructions that we will learn in this internship only. You will learn more about it during EDA. EDA basically elaborate data analysis. In that, you will see that how we are clearing the data, then how we are rearranging the data, then how we are going to find the insights from that data. Sometimes we use mean median mode also in order to perform some operations on data. At that time, some maths concept will get introduced, but don't worry, we will explain it to you. They are very basic.